Intro. So Pluto, right? That little dwarf planet way out there that used to be one of the real planets? Well, it seems like it's back in the news thanks to some pretty surprising ideas from big-name scientists like Neil deGrasse Tyson and Michio Kaku. They're suggesting that Pluto might actually be on a crash course with Neptune. Now, how could something like that even happen? And what would be the result if these two actually collided? Is this just a weird one-off thing in space that we're seeing? Or is there something bigger going on here? Let's see what's up with all of this. Even though Pluto got bumped down to dwarf planet status, partly because of how weird its orbit is, it's still a source of questions for astronomers. The latest buzz is that some scientists are saying Pluto's path is getting way too close to Neptune's, and it's not just some random people. It's Tyson and Kaku who have made the statement about a possible impact. A crash between these two could possibly even cause problems here on Earth. The first thought is, how is that even a possibility? Pluto's orbit is not like the other planets. It takes Pluto a crazy 248 years just to go around the Sun once. To put that in perspective, it was only discovered in 1930, and it hasn't even made a full circle yet. And it gets weirder. Pluto's path isn't a neat circle like most of the other planets. It's more of an oval, which scientists call elliptical. On top of that, it's tilted compared to the other planets, like it's on a slant. This tilt and oval shape make its orbit super strange. One of the craziest things is that Pluto's orbit actually crosses Neptune's for about 20 years of its orbit. For that time, Pluto is actually closer to the Sun than Neptune. This brings up a pretty simple question. Why haven't they smashed into each other already? The answer has to do with gravity from other planets affecting them. When it was first discovered, people had a hard time figuring out just what Pluto did out there. Unlike the paths of the main planets, its orbit looked tilted and not very circular. This became even weirder when they learned that Pluto and Neptune's orbits met. The fact that Pluto is still cruising along without hitting Neptune is a testament to how complex things are in space. The movement shows that the gravity of Neptune and the Sun interact to affect where Pluto goes. The solution as to why things are stable is something physicists call a libration with Pluto and Neptune. What it means is that when Pluto is crossing Neptune's orbit, it's always super far away from Neptune itself, at least 90 degrees apart. So they never get close enough to bump into each other. Pluto also moves vertically, and when it's nearest to Neptune, it's either far above or below Neptune's path. There is also something that is called VZK oscillation. That's how they move relative to the Sun. This helps to explain why Pluto's path is so unusual. It makes sure Pluto moves smoothly instead of erratically. All this stuff keeps Pluto's orbit steady so it doesn't hit Neptune or go flying off somewhere else. It makes the whole solar system more predictable. If this weren't the case, things like Pluto could get thrown off course and wreck into stuff. Computer tests from the 1980s showed that Pluto's orbit can change a lot with only minor changes to how scientists first calculated where it was going. Add on to this that Neptune and Pluto fall into a 3-to-2 orbital resonance, where for every 3 times that Neptune orbits the Sun, Pluto orbits twice. Furthermore, Jupiter and Saturn, the other large planets, all work to help keep Pluto's orbit as it should be. Because of this strange coupling, it's even more important for maintaining a sense of order throughout the solar system. Furthermore, without being able to guarantee that bodies like Pluto will orbit correctly, the entire system would enter a state of total chaos. The bottom line is that even seemingly unstable orbits can work out and come to an equilibrium through this crazy interplay of gravity. These computer models are really useful for figuring out what's going on. They use math to show how Pluto and other things in space impact each other. Tiny changes in these models can make a huge difference in where Pluto ends up. Predicting these kinds of events with Pluto's chaotic orbit is super tough. These systems are so unpredictable that it's hard to know what's going to happen long term. Though these simulations are great for understanding, they only highlight how tough it is to actually guess what's going to occur. These models depend on knowing the correct details from the start. Any small flub can lead to big differences down the line. Even with the giant planets trying to keep something like this from happening, why are Tyson and Kaku only mentioning this sort of collision now? Tyson is famous for making science easy to understand, and he's got some thoughts about Pluto. He believes that as more space is discovered, classifying Pluto as a dwarf planet is what makes sense for our broader understanding of the solar system. He sees how hard it can be to determine where something like Pluto can go years in advance, but always focuses on continuing to learn. Kaku is always looking into the future, believing the need to model and observe needs to be maintained to see any potential problems in advance. He sees any possible interactions as vital to understanding how space works on academic and practical levels. Tyson and Kaku both mostly think that space keeps getting more difficult to fully comprehend and that models have to keep improving as tech gets stronger. Ultimately, there is a scientific thought that Pluto's and Neptune's orbits are stable at the moment, but in the end, it is important to monitor and continue to work on any long-term risks by scientists and astronomers. Pluto, that little dwarf planet. Pluto, that little dwarf planet way out there, used to be one of the main planets. But guess what? Some big-shot astrophysicists like Neil deGrasse Tyson and Michio Kaku have been talking about Pluto again. They've got this idea that it might actually crash into Neptune. How could that even happen, and what if it did? Would it be a big deal for us? Scientists are looking into whether this is just a weird space thing or something more. Pluto's always been a bit of an oddball. It got kicked out of the Planet Club partly because of its crazy orbit. Now, some folks are saying it's getting a little too close to Neptune. Tyson and Kaku are even warning about a possible crash that could mess things up for Earth. Seriously. So how could this be possible? Well, Pluto's orbit is super strange. It takes 248 years to go around the Sun just once. Since we found it in 1930, it hasn't even finished one trip. Plus, its path isn't a neat circle like the other planets. It's more like an oval on a slant. And here's the crazy part. Pluto's orbit actually crosses paths with Neptune's. For about 20 years during each orbit, Pluto gets closer to the Sun than Neptune does. So why haven't they smashed into each other yet? Other planets' gravity is the reason. When Pluto was first spotted, astronomers were scratching their heads about its weird orbit. It's tilted and oval-shaped, unlike the other planets' paths, and the fact that it crosses Neptune's orbit just made things even weirder. The fact that Pluto's orbit is stable shows just how complex space stuff can be. Think of it like this: you've got Pluto, Neptune, and the Sun all pulling on each other. It's hard to figure out where they'll all end up. In Pluto's case, it's like Neptune and the Sun are playing tug-of-war. Scientists use terms like oscillation to explain this. Basically, when Pluto crosses Neptune's path, it's always far enough away to avoid a collision. Another thing is that Pluto moves up and down a lot in its orbit, so when it's closest to Neptune, it's usually higher up, which keeps them from hitting each other. Add to that the way the Sun's gravity affects them. It turns out that even if Pluto's path looks strange, these oscillations help keep it steady over the long run. It shows that even in space, there's order to be found. Final thoughts and what's next for JWST. Even if it looks like chaos, all this stuff keeps Pluto from crashing into Neptune or getting lost in space. Back in the 80s, some computer simulations showed that Pluto's orbit is a bit unpredictable. Tiny changes could cause big differences over time, but it turns out that Pluto's orbit is stable over a really long time, billions of years, actually. Scientists use computers to see how the big planets, Neptune, Jupiter, and Saturn, affect Pluto's path. For every 2 times Pluto goes around the Sun, Neptune goes around 3 times. This helps keep Pluto in a steady orbit. But Neptune's not the only one helping out. Jupiter's gravity also keeps Pluto safe, and Saturn chips in too. Jupiter's gravity is strong enough to keep Pluto on track for billions of years. So it's like Neptune, Jupiter, and Saturn are all working together to protect Pluto. Without these things, our solar system would be a much more chaotic place. Planets could crash into each other or get thrown out of the system. That's why understanding Pluto's orbit is so important, especially since people are talking about it hitting Neptune. It gives us a better understanding of how our solar system works. Pluto's story shows how even unstable-seeming orbits can find balance thanks to gravity and the way things move in space. It also reminds us to keep watching and studying these things so we can learn more about our place in the cosmos. Space is wild, and Pluto's orbit proves it. Its path can change a lot based on tiny things. Even though Pluto has things that make it steady, its orbit can still be pretty crazy. Start with a small change, and its path can look totally different after millions of years. But even with all that chaos, Pluto's orbit stays stable for billions of years. Predicting space stuff, especially with crazy orbits like Pluto's, is hard. These systems are so unpredictable that it's tough to say what will happen in the long run. Computer models help, but they're not perfect. Small mistakes can lead to big differences, so it's hard to make exact predictions. The wild nature of orbits like Pluto's reminds us that the universe is always changing. Even though we've learned a lot about space, Pluto shows us that there's still so much we don't know. Understanding how the big planet's gravity affects Pluto's orbit tells us a lot about how the solar system works. It shows how each planet can change the way other planets move. So why are folks like Tyson suddenly worried about Pluto hitting Neptune? Well, Tyson has been saying that the more we learn about space, the more questions we have, and Kaku thinks we need to keep watching space closely because things can be pretty unpredictable. They both agree that space is full of surprises and that we need to keep exploring and learning. Even though most scientists think Pluto and Neptune are safe for now, we still need to keep an eye on them to see what happens in the future. Better telescopes and computer models will help scientists make better predictions. Tyson and Kaku remind us that we need to keep exploring and be ready to change our minds as we learn more. The idea of Pluto hitting Neptune shows us how complex and exciting our solar system is. It reminds us that there's still a lot to learn about space, and we need to keep exploring to find out what's out there. As we dive deeper into understanding Pluto and its place in the solar system, it's important to consider how its unusual orbit fits into the broader mechanics of celestial bodies. Pluto's orbit, though chaotic in appearance, has been remarkably stable over billions of years. However, even this seemingly calm system may not be set in stone. Scientists, including Tyson and Kaku, emphasize the need for constant monitoring, as subtle shifts over long periods could potentially lead to more dramatic changes. One fascinating aspect of Pluto's orbit is its resonance with Neptune. This 3-to-2 orbital resonance, where Neptune orbits the Sun 3 times for every 2 orbits that Pluto completes, keeps the 2 planets in sync. This natural balance prevents a collision, as it ensures that Pluto and Neptune can never be close to each other at the same time in their respective orbits. This cosmic dance, although predictable now, wasn't immediately obvious when Pluto's orbit was first discovered. It took years of observation and computer modeling to understand why the 2 planets haven't collided despite their overlapping orbits. The resonance between Pluto and Neptune highlights a key principle in celestial mechanics: the idea of gravitational interactions between planets. The combined gravitational influence of Neptune, the Sun, and other outer planets like Jupiter and Saturn all work together to stabilize Pluto's orbit. If one of these forces were suddenly altered, say through a shift in the orbit of a major planet or the influence of a nearby star, the balance could be disrupted. In a worst-case scenario, Pluto's orbit could become more erratic, leading to a potential collision with Neptune. However, such an event is highly unlikely in the near future due to the immense gravitational forces at play. There's also the matter of Pluto's small size and mass. Unlike the larger planets, Pluto doesn't have the gravitational pull to significantly alter the orbits of other objects in the solar system. Its interaction with Neptune is influenced more by the larger planet's gravity than Pluto's own. This asymmetry in size and mass further adds to the stability of their orbits. The gravitational tugs from larger planets, like Jupiter and Saturn, help ensure that Pluto stays within a relatively stable region of the solar system. Additionally, the long-term stability of Pluto's orbit is essential for understanding the entire solar system. Astronomers rely on models of planetary motion to predict the behavior of not just Pluto, but also other objects in the Kuiper Belt and Oort cloud, areas filled with icy bodies and dwarf planets. The movement of Pluto and its relationship with Neptune provide valuable insights into the dynamics of distant regions in our solar system. Any disruption in Pluto's orbit could set off a chain reaction, potentially altering the paths of other objects in the Kuiper Belt and beyond. This ripple effect underscores the importance of studying these far-off bodies, even if they seem small and insignificant compared to the major planets. Space missions like the New Horizons probe, which made its historic flyby of Pluto in 2015, have offered a wealth of data about the dwarf planet and its moons. These missions provide scientists with the ability to test their theories and models against real-world data, which is crucial for understanding how the outer regions of the solar system function. With each new discovery, our understanding of the intricate gravitational relationships between planets and other celestial bodies continues to evolve. Moreover, the study of Pluto and its orbit is a reminder of how dynamic and ever-changing the universe is. While the forces that govern planetary motion are well understood, space is filled with countless variables that make predictions extremely difficult. Even with the best technology and most sophisticated models, the true complexity of the cosmos is still far from fully understood. The possibility that Pluto's orbit could change due to a variety of factors, including gravitational interactions with distant objects or the influence of rogue planets or passing stars, serves as a humbling reminder that we are still only scratching the surface of cosmic knowledge. Tyson and Kaku both agree that the key to understanding space lies in continuous observation and research. With advancements in telescope technology and computational models, scientists are now able to track the most minute details of distant objects like Pluto. As we continue to learn more about the intricacies of space, we may uncover new phenomena that challenge our current understanding. Even though Pluto's orbit seems stable for now, it's a perfect example of how the universe's complexity is constantly unfolding, offering endless opportunities for discovery.